My name is Aleksandra Koprowska, and I am a PhD student at Hearing Systems section at the Technical University of Denmark. I will introduce my study on training synchronization with musical beat to improve speech perception in individuals with hearing loss. This project is running in collaboration with an industrial partner, WS Audiology. Hearing loss is a widespread problem that affects mostly elderly individuals and causes major difficulties in everyday communication. The typical remediation strategy are hearing aids, which successfully improve listening comfort in many situations. However, 1/3 of hearing aid owners still report that they are not satisfied with the performance of their devices when trying to follow conversation in noise. Therefore, there is still need to develop auditory rehabilitation strategies that would complement provision of hearing aids and hopefully provide higher benefits. And auditory training is one of them. It has been proposed that training musical skills could benefit speech intelligibility in hearing-impaired listeners. Among many aspects of musical aptitude that could be targeted in our training program, we identified sensitivity to musical beat as a promising candidate, since we know that beat perception skills strongly correlate with speech in noise performance. The aim of this study is to design and implement a training program that would improve synchronization with musical beat and assess its effects of speech intelligibility in elderly hearing aid users. We developed a mobile application that used musical stimuli varying in tempos. The user's task was to listen to the music and tap along. We designed a graphical interface that would help the user understand the task and provide visual feedback. When participant started tapping on the red button, the red circle would start moving. The position of the black circle relative to target would inform the user whether his response was on beat or not. In addition to that, the number of correct, early, and late responses would be displayed on the screen. The training was administered at home, and every participant was equipped with a mobile phone and headphones. To compensate for hearing loss and ensure audibility, we pre-processed all the stimuli by applying individual gain. The study was designed as a randomized controlled trial, and participants were assigned to two groups, the training group and an active control group that received another version of a mobile application and performed approximately the same amount of listening exercises throughout the period of 3 weeks. Pre- and post-training assessment comprised measure of beat perception and production and speech intelligibility in noise, and was administered in the lab. As a measure of beat perception and production performance, we selected a beat alignment test, and we focused on two exercises: the synchronization with the beat of music, where participants had to tap along with 12 music excerpts, and perceptual judgment of the beat, where participants had to respond whether a sequence of tones played simultaneously with a musical excerpt was aligned with the beat or misaligned with the beat. To assess transfer to speech domain, we administered two Danish sentence tests, Dantele to and hint, which varied in their rhythmical properties. We used two different types of masking noise, one with amplitude that was constant in time, and modulated noise, where the amplitudes was periodically changing over time. We recruited native Danish speakers who all suffered from mild to moderate hearing loss. They were experienced hearing aid users, and none of them received musical education longer than 2 years. At the moment, 11 participants completed the study. To assess the progress in training program, we analyzed tapping data collected over the period of 3 weeks using circular statistics. The tapping times in each trial were converted into degrees, and the mean resultant vector was computed. The angle theta represents accuracy, and accuracy value of 0 means that the tap occurs exactly on the target beat. Another metric was consistency, and this one corresponds to the length of the resultant vector. It has value from 0 to 1, and the higher this value, the more consistent participant responses. Both accuracy and consistency for each participant is a value averaged across all trials within 1 week of training. We observed trend of improvement for 2 of our participants. The other 2 participants show no sign of improvement. And the other 2 participants showed very modest amount of improvement, possibly due to ceiling effects, because we can see that their accuracy scores were already very good at the beginning. To evaluate the generalization of training effects on untrained beat perception and production tasks, we analyzed the results of beat alignment test administered before and after the intervention. For the synchronization task, we computed coefficient of variation, and the decrease of this value from pre to post session would indicate improvement. On the left, we can see results for the training group, and on the right for the control group. For the perceptual test, we computed the percentage of correct responses. We can see that results of this outcome measure correspond quite well with what we observed in the training data. So participants marked in green that improved throughout the training also show trend of improvement for outcome measures for all but 1 instances. The participants marked in dark red that did not improve over the training do not show any sign of improvement on these outcome measures for all but 1 instances. And we can also see something that corresponds to the ceiling effects observed for the other 2 participants. And finally, to investigate the transfer to speech domain, we analyzed the results of our speech tests. For each condition, we derived speech recognition threshold, which corresponds to signal-to-noise ratio, at which 50% of speech material was correctly repeated. And a decrease in this value would indicate improvement. When we look at results for Dante 2 and 2 maskers, stationary noise and modulated noise, we can see that only for modulated noise, there is a consistent trend of improvement for all participants in the training group. However, we see a similar phenomenon for the control group, which means that this change should probably be attributed to some test-retest effects rather than to enhancement of perceptual skills due to training. For hints in stationary noise, we see modest but consistent trend of improvement for training group. However, due to small sample size, we cannot at the moment conclude if this is a significant change. So to sum up, this study demonstrates the implementation of a training program based on synchronization with musical beat and the primary evaluation of its effect on speech intelligibility in older hearing aid users. Our main findings are that the amount of improvement in the trained task differs across participants due to different factors, for example, baseline performance. And changes observed in the beat perception and production outcome measures appear to be in agreement with trends observed throughout the training. But no clear transfer to speech in noise outcome measures has been observed so far. And of course, more extensive data collection is needed to properly assess the effect of training on speech intelligibility. I would like to thank all our collaborators and thank you for your attention.